Welcomes to you dear student in this past paper series. This is Cambridge O level physics 5054 May June 2025 paper. In the last session we have solved question number 2 and in this session we are going to solve question number 3. This is question number 3. First of all, read the statement very carefully. Which statement explain why a heavy coin? It means we have a heavy coin that falls. The coin is falling toward the ground through a short distance. Distance is very short. Toward the ground doesn't reach terminal velocity. It means we have to understand firstly what is the terminal velocity in a detailed way. And it's just about this is a heavy coin, its mass is very heavy, and this is ground level, this is falling toward the ground, this is very short distance. This is all about this scenario. First of all, we will understand what is terminal velocity in our worksheet. This was our last question. Now overall scenario is, this is a coin, its mass is very heavy, and this is ground level, coin is falling toward the earth. Let me draw some lines here. These lines represent air between the coin and the ground. It means when coin fall toward the ground, there is air resistance that try to oppose its motion. Air resistance opposes its motion. It means there is upward force due to this air, and this is known as a drag force. This is known as drag force, that is acting vertically upward. This is known as drag force, F and D. This is due to air resistance. Due to air resistance. This is due to air resistance. And this coin is falling toward the ground. There is another force. This one is a force that acting vertically downward. This is its weight force, F and G. This is weight force. Weight is acting vertically downward. This is weight force, F and G. This is due to gravity. It means our coin is under two opposite forces. Upward directions there is a drag force, downward direction there is a weight force, that is gravity. Let me show you what is going here. First of all, this is the drag force. Drag force is equals to 6 pi eta r v, and weight is just m and g. What is important in these two forces? This one is fixed throughout its journey. This one is fixed. Weight is fixed near the ground. Near the ground, mass is fixed, G is fixed, so weight is fixed. This force is fixed. As the coin is falling, there will be no variation in this force, but there will be variation in this drag force, as it depends upon speed or velocity of this coin. This part is a constant. This is 6, this is pi, this is eta is viscosity of this air, and r is the radius of this coin. It means overall statement, overall this factor is constant, 6 pi eta r. This is a constant number. Only velocity is varying, so drag force is varying. How it's varying? Let me show you once again. First of all, let's say this is a weight force. and this is a drag force, and this is its velocity, and this is the coin is falling downward, and upward force, this is force due to air resistance, this is velocity dependent force, this is a fixed force. So I can write, let's say the weight of this coin is 10 Newton. Let me assume some points here for better understanding. Let's say this point is A, this is point B, and this is C, and this is D. D point is very close to the earth, or you can say at the point D this coin touch the earth surface. And I just draw this table for point A, point B, point C, and point D. This will remains fixed in overall journey. There will be no change. This is point D. In this force, as we have discussed, gravity or weight force is fixed. First of all, at point A. At point A, the coin is almost constant. And at point A, the coin is fixed. There is no velocity. So this is at rest. At point A, this is at rest in our hand. So there is no motion. So velocity is 0. Simply, I can write, if the velocity is 0, then drag force will be 0. So there will be no resistance, air resistance upward directions. If this increased up to 2 meter per second, this increased almost 4 Newton. If this increased up to 5 meter per second, roughly, this will increase up to 6 Newton, let's say. These are the rough numbers. And before hitting the ground, its velocity is 6 meter per second, let's say. This constitutes the force of 8 Newton. How? It means this coin require a velocity. This is very important point that I am trying to explain here. It means this coin require a velocity that make this drag force equals to weight, and it means all is about velocity. If velocity reach up to a particular value, this make this force equal to this weight force. It means we require this velocity. This velocity is known as critical velocity or terminal velocity. This is known as a terminal velocity. We require a terminal velocity at which this drag force become equals to weight. Fg is equals to F and D. These two become equal, then this velocity is known as terminal velocity. It means at terminal velocity both forces become equal. And we need a value, but before attaining this value, this coin fall toward the ground due to short distance. There is problem is of short distance. As the distance is short, so velocity is not enough to make this weight equal to this one. Hope my concept is clear to you. Velocity is not enough to make this drag force equals to this weight. It means weight is always higher than this drag force. It means we need a particular velocity at which this drag force become equal to weight. Here is the point to be discussed. It means if velocity, or simply if drag force equal to weight force, if this one equal to this one, then the velocity is known as terminal velocity. It means to attain a terminal velocity, these two forces become equal, or to make these forces equal, velocity must be equals to terminal velocity. But in our case coin is heavy, so distance is short. To attain terminal velocity distance must be higher. But in our question statement it's clearly stated that the distance is very shorter. It means coin hit the ground before reaching this terminal velocity. That's why our weight is always, our weight force, this one, is always greater than this drag force, or you can say that this drag force, or you can say that weight is always greater than air resistance. Now comes to our point, the coin has not hit the ground. This is not the problem. Coin, definitely if you fall, if you leave this coin, this will hit the ground definitely. There is no other force that can sustain this coin into air. This is not the case. The weight of the coin equals to the air resistance. This is not the case. If this one is equal, then gravity force will become equal to its drag force. Then there will be a terminal velocity. It means the weight of the coin equals to the air resistance. This is not the case because it doesn't reach the terminal velocity. If it reaches the terminal velocity, then this is the case. The weight of the coin increases as the air resistance increases. But the problem is that weight is always a fixed quantity. I have discussed in start, this is due to gravity. M is fixed, G is fixed. Both are fixed quantity. Weight cannot increase. The weight of the coin increase as the air resistance increase. Weight not depend on any values. It only depend upon G. So it's fixed. The weight of the coin is always more than air resistance. This is the case. This is not the case. This is the case. The weight of the coin is greater. This is our true statement. The weight of the coin is always more than the air resistance. This is the case here. The weight of the coin is greater than the drag force, or you can say this is drag force is actually what it is, air resistance. This is air resistance. So our right option is option D. This is all about question number 3. Thanks for watching.